And so. Oh, you're doing great. You probably couldn't hear me.
Okay. Yeah, it sounds like we've taken care of all the business for the Audubon. So I think at this point we can turn it over to you. So if everyone could make sure their microphones are muted, and David, we'll let you take it away. Thank you for joining us tonight.
Awesome. Thank you so much, everyone. It's a pleasure to be here again. This is so much fun. I love doing a series of talks like this. And I don't get to see the audience, but I know there's an audience there and we have some people at home. Thank you everyone for coming out. I think this is our fourth talk in a row. So I appreciate this opportunity to actually build out a series of topics and to explore the world of birds in a number of different ways. I probably don't need to introduce myself at this point, but just in case there's new people here. Um, I'm David Lucas, and I have spent my life working as a freelance naturalist. I spent 12 years in Yosemite leading hikes and have led thousands of hikes and classes and workshops. I wrote a book on Sierra Nevada birds. I wrote a book on Bay Area birds. I wrote or revised the book Sierra Nevada Natural History. So I'm deeply embedded in this telling stories about the natural world and sharing incredible stories. And in case you don't already know, my most recent project is a weekly newsletter at lucasguides.com. Check it out. I cover some incredible topics every week. And I would love to have you join. I love to share natural history stories with you as we are tonight. So please sign up and please follow along. And with that, let me go ahead and just get started on the talk here. Let's see. So before we get started, I want to emphasize that this is an educational program. And so in this talk today, I'm going to be using a number of diagrams from this book. I think I recommended this before because this is such a great book. Boy, this Handbook of Bird Biology, and there's a newer edition than this, even this is the older edition. Big, heavy, thick book. It's hard to pick it up, but it's full of excellent diagrams. Really easy to read, understand. It's a fantastic learning tool. You can just open it and flip through different sections and learn so much. So a lot of my diagrams have come from this book, and as you'll see, they're excellent diagrams. So I can't recommend this book highly enough. And then I also have a variety of images from the internet. These aren't photos I took. I'm just using them to illustrate some of the points in this presentation we're going to cover. Um, and we're going to focus today on bird nests and eggs. The season has already started. I'm sure that some hummingbirds are already nesting there. We still have a lot of snow up north where I live, but it's full-on springs happening there. So it's a really exciting time of year. Birds are showing up, they're singing, they're courting. Some of the really early ones are even starting to think about uh, laying eggs and building nests and stuff. This is one of the most important parts of a bird's life. And one of the things I want you to keep in mind as we go through this whole presentation is that this act of nesting is a calculated risk for birds. So birds are always hyperactive. They're always flying around quickly in search of food or getting away from predators. So sitting in one spot and making yourself vulnerable for predators for weeks at a time is going to be a dramatic departure from your typical avian lifestyle. But at the same time, if you're laying eggs and protecting them in a secure nest, it's going to provide some critical advantages because it's like having an external womb that frees up the female to fly away and escape predators, and it allows both parents to participate in all aspects of raising their babies. So there's some real advantages to it, even though it is a dramatic departure from their lifestyle. And there are so many different variations on the themes of birds nesting, and that's why it's a fascinating topic. We're going to focus on the general view, but I want to just acknowledge that there are some incredible exceptions to this general rule. So, for example, we have emperor penguins, that the males spend months huddled together in the continuous nighttime of the Antarctic winter. They're not eating for months at a time. They sit there cradling their egg on their feet to keep it off the snow. There's 60-mile-an-hour winds, it's negative 150-degree wind chill. And then when the chick hatches, the male feeds it a thick soup that it derives from the lining of its esophagus. And it feeds it while not eating until the female finally arrives with the chick's first fresh meal as the spring arrives and relieves the male of his duties. So that's one example. We also have something like the example of hornbills in the tropics. And in this case, the females go into a tree cavity. Then they use mud to seal themselves inside of the tree cavity, leaving only a tiny slit, and they rely entirely on their male to bring them food for, close to a month until the chicks are ready to start fledging. And then we have an example, a completely different example of the male Australian brush turkey, which constructs these mounds of vegetation, decaying vegetation. These can be 16 feet high, they can be 40 feet across. And the male pokes its beak into the mound. He's continuously monitoring and adjusting the internal temperature of the mound of decaying vegetation. He's going to be adding and removing vegetation. These massive mounds are used by generations of males for over 1,000 years, and then the females are going to be attracted to males based on the quality of the mound he maintains. They're going to lay their eggs and then depart, never seeing their chicks. And so there's just like these are just wildly different examples of different ways that birds nest and raise their young. But tonight we're just going to focus on a general view of the way that birds basically nest and raise their eggs and their chicks. And as I said, we're going to focus on nests and eggs, but I want to first set the stage and talk a bit about territory and courtship. And then later at the end of the talk, we're going to talk about chicks after they hatch, but we're mostly going to focus on nests and eggs. And again, we're going to be just covering a very generalized view because there's just too many exceptions and too many unusual cases for us to cover them all. So while breeding and having young is going to be critical for birds, I want you to keep in mind that reproduction is always going to be a trade-off between output and risks. So you're going to have a number of babies, but you're going to incur risks to yourself. And it's all going to start out before any nests are built or before any eggs are laid. So the act of claiming a territory and singing and engaging in courtship displays are all going to be very high profile activities that attract the attention of predators. And at the same time, having a territory matters, and females are not going to mate with you if you don't have a territory, because a territory is going to be a place of safety where you have exclusive access to food and you're not going to get interfered from competitors. It's your own place to raise your babies. And ultimately, a female wants to have the best resources for her chicks. And these resources are going to include both the resources on the male's territory and the genes that the male offers. What does he bring to the mix? Well, it's interesting that it seems that the territory is far more important for females than the male himself, because a female can simply sneak off and get a copulation with any other male in the neighborhood. And so she doesn't care. She can just go around and get whatever gene she wants, but the territory is the choice that she's making. She's choosing him for his home, not for him. And even before we get into talking about nests and eggs, I want to consider these trade-offs between output and risk and how this impacts breeding strategies, because it really does matter. So when a bird is breeding, it has to assess how long am I going to live, and do I want to put all my effort into one breeding season and wear myself out, or do I want to take a more cautious approach and save my body and my energy for future years? So if you're a larger bird like this albatross, they produce about one egg every 2 years, but adults have 95% survival rate. So they're almost guaranteed to be around for future breeding seasons. So if they produce one egg every 2 years, it's not a big deal because they're going to have many, many rounds of breeding. But if you're a smaller bird, you might produce 15 young in a single summer, but half of the adults are not going to survive until the next year. So it's all or nothing. You have a 50% chance of dying, so you want to throw everything you got into one breeding season. And this immense effort is going to be worth the risk because it might be your only breeding season. But it's even more of a gamble than this, actually, because any bird that maximizes its reproductive effort 1 year probably isn't going to recover enough to breed again the next year. And at the same time, another individual of the same species that has fewer young and it's saving some of its energy, it's going to keep producing young for several years if it survives. So there's just all these different pros and cons, pluses and minuses that birds have to be juggling all the time. And if your primary focus is increasing your reproductive output, how many babies can you have in your lifetime? Having one babies is not the only option. You can also increase reproductive output by ensuring that more of your babies survive. So it's pretty common for 50% of all nests to be lost to predators. So you want to hide your nests from predators. And if you do, you end up with more babies without wearing yourself out. And many birds use this strategy. They work on hiding their nests, but not all birds do this. So let's think about like a colony of gulls nesting on the sea rocks. The safety there is in numbers, not in hiding. So they want to have a mob response that they can all get together and chase off a predator or defend themselves from threats. So that's the strategy there. There's also going to be a significant difference in your nesting success if you have one or both parents helping guard the nest and helping feed the babies. So in a bird like red-winged blackbirds, the most successful males have harems of females, lots of females in her harem. So a female can choose. She can choose between being part of a harem on a high quality territory and raising the babies by herself, or she can have a male to herself on a low quality territory and have him help her. Well, it turns out that raising babies by herself on a high quality territory is usually the better choice for birds. And another fascinating example are dark-eyed juncos. So they should be showing up now and hopping around. So you see them all the time. Maybe they're even starting to do some courtship and singing. In the case of dark-eyed juncos, the flashiest males with the sweetest songs are terrible fathers because they're busy showing off. They're preoccupied with showing off. And it's the mediocre males who realize there's no point in showing off, who are great fathers. So what's so fascinating about this is that the older, more experienced females always choose to mate with the young, sexy studs, while the younger, inexperienced females pick mediocre males. So why is this? Well, it turns out that both of these strategies are good choices. So if it's a year with lots of food, females who mate with the studs who are terrible fathers, they get the best genes and they have no problem finding enough food to raise their babies with no help from the male. But in years when food is scarce, the females who mate with the mediocre but diligent fathers are going to be more successful because it takes two parents to find enough food in a bad year. So in general, it's kind of a balance, whether it's a good year or a bad year, which males work, but overall, every strategy works. They're just different solutions to the same problem. In general, it's better though for parents to be monogamous and for both parents to help at the nest because that's a lot easier, as you'll see later, for two birds to raise hungry young than just one bird. And in many ways, this nest is the centerpiece of a bird's breeding season. It's the place that's going to hold and protect the eggs and babies. And in the best cases, it even hides babies from predators. It's also a place for sleep and a place for courtship. So let's talk about courtship. For birds, flight is everything. And so in order to fly efficiently and quickly, a bird cannot afford to carry around extra weight. And this means that males and females have to perfectly coordinate their reproductive readiness. In the case of males, their testes can grow several hundred times in weight and volume in the breeding season. And so you only want to carry these big, heavy testes for the shortest period of time possible. And in the case of females, eggs weigh a lot. So females want to produce, fertilize, and lay their eggs very quickly. It turns out that the activities of courting with each other and building a nest triggers their ovulation and their courtship cycles and synchronizes their reproductive readiness so they're both ready to mate at the same time and then they can shed the weight at the same time. It's a very effective kind of synchronized behavior, which works really well for birds. Timing is also going to be important because you want to match the hatching of your babies to coincide with peak food availability. So in the case of great horned owls, which are already on the nests, they want to start nesting in late January or early February so that their babies come off the nest and begin hunting on their own at the same moment that baby mammals and baby birds from other species are out fumbling around the world and easy prey for baby owls to catch and learn how to hunt. And in case of goldfinches, their timing is completely different because they eat grass seeds, and grass seeds are most plentiful in late summer. So they want to time their babies to be ready in late summer. So they nest late in the year. It seems like the only bird that's really not dependent on a specific diet or a specific season is pigeons and doves. And the reason is because whatever pigeons and doves eat, they turn it into what's called pigeon milk in their esophagus. And they kind of vomit up, I guess, cough up milk from the lining of their esophagus. And they feed the babies the same diet no matter what the parents eat. And this means that parents can choose from a whole range of foods and they can produce many clutches of babies over a very long breeding season. This nest is a remarkable structure. Here we have robins, and it requires a tremendous investment of energy. So in the case of barn swallows, they make about 1,200 trips to collect the materials they need for their nest. An oriole might need 3,400 grass stems to build its nest. A woodpecker might need to hammer at a tree 100,000 times to make a cavity. This is a lot of energy investment to make whatever kind of nest you're making. The smallest nest in the world is a bee hummingbird that is less than an inch wide, and the largest known nest was a bald eagle nest that was 20 feet high and 10 feet across. So a female might do all of this work herself, and the male, he might do nothing. He might work equally hard, or he might bring the materials to the female that she then weaves into the nest. Ultimately, the female is going to decide where the nest is going to be because she's the one that's going to be sitting on it mostly. The male might display near a potential nest site on his territory and check it out and say, come check it out. Like, so male marsh wrens, for example, will build 20 different courting nests on his territory. And then he shows the female each of these 20 nests to show off his prowess and show how good his territory is. And if she likes him, she's going to pick one of these nests and then finish it out. But he's going to build these sample nests and say, hey, this is what I can do. What do you think? And if she likes them, then she'll finish it. And sometimes females make really unusual choices and nest in the goofiest spots. So there's records of birds nesting on slow-moving trains or nesting on ferries that are making continuous daily runs back and forth. And there's many, many other examples like this. So it's clear that birds are flexible in their choices. And many birds build a new nest every year because old nests break down and are also full of parasites from the previous year. But many other species then reuse old nests or they'll steal the nests from other species. And if a bird nests several times during the breeding season, it will often nest in different locations. So in the case of song sparrows, for example, they build several nests. Their first nest is usually on the ground, and then their later nests are going to be located in shrubs once shrubs start leafing out. So birds are picking different spots to nest. We'll talk about the different kinds of nests in a moment, but let's look at how a basic nest is built. So take the case of a robin, a very familiar bird. And robins are an example of birds where the male closely attends the female, and he will even bring her nesting materials as she builds up the nest, but he doesn't actually make the nest himself because she's going to do all the work of sitting on the egg. So she needs the nest to fit her body. It won't do any good if he builds it and what he thinks is the right design. It's not going to fit her. She needs to build it and fit it to her body. So a typical songbird nest takes 6 days to build, 3 days to make an outer wall and a foundation, and then 3 days to add the lining to it. Their first step is building out this outer wall. They're going to be using coarse materials like stems and small branches. These are soft and pliable so they can be bent into shape. And she's going to build up this outer wall and then press her breast in it and turn and move and pull sticks in and out around her body, kind of shaping the basic form to her body. And then once she's built up the outer wall, she's going to continue adding more materials. And in the case of robins, they line it with mud. They will go out with a little wick of grasses or moss and kind of sponge up some mud, carry it to the nest, and then dab it on with the sponge at the places they want it. And as she builds out the mud lining, she'll get in it and turn and push her body into it and form the mud to the shape of her body as it dries. So that by the time it dries and makes a cavity, it's exactly her shape. So she'll be comfortable as she sits there. And this can take 6 days, as I mentioned, but if a robin loses its first nest and has to rebuild a new one, which will happen sometimes, it can build a new nest in 2 to 3 days. So that's a typical pattern. And what's amazing about bird nests is that they can use some really complex weaving and knotting techniques. So here's some examples of knots used by an African weaver finch, one species of bird. This is the kind of knots that this bird uses to make its nest. And all of this is done with their beaks, which seems like a clumsy tool, right? And they're doing this with raw, cumbersome natural materials, trying to bend it in the shape and knot it up and make their whole nest. It's really an incredible process. So there's a variety of different kinds of nests the birds of the world make. You might have no nests in the case of these murres. They just kind of scoop out some dirt, plop their egg right there, and that's their nest, right? You might have a simple scrape, like here's a killdeer nest here, just basically a simple scrape, a few items in it. You can have a platform like this coot right here, basically just mounding up a few materials. Ospreys, herons, mourning doves kind of all do this. You can have a domed nest on the ground, like a meadowlark or a snipe, where it'll make kind of a roof over it. It's just a nest sitting in the ground, but to protect it. And so predators going overhead or walking by don't just see eggs sitting there. It's actually kind of protected and also protected from the elements. You can have a globular nest, like magpies, cactus wrens do this too, just a big giant, I don't know what you call it, a mess of branches in a tree with a hole in the center somewhere. You can have what are called retort nests, like cliff swallows do this, kind of a gourd with a neck on it. You can have burrows. So here's the case of cliff swallows. We also have, oh no, not cliff swallows, sorry, bank swallows or burrowing owls, belted kingfishers. These these burrows can go back about 15 feet in the case of kingfishers. That's pretty amazing. And then we have cavities like woodpeckers and nuthatches and chickadees that either make their own cavity or use some other cavity. But when we look at all these types of nests, we are missing the one type of nest used by most birds in the world. And what is that type of nest? Well, it's the cup nest. And there's different kinds of cup nests. I don't expect you to memorize these. I just want to illustrate that there are different kinds of cup nests, and even more than that, there's different kinds of nests that birds are making. But the typical cup nest is what's called a statent nest. And this is built on any kind of hard physical support, a crow, robin, hummingbird, they're building it on branches. In the case of this black-headed grosbeak, they do a unique strategy where they make the nest so flimsy that it doesn't even look like a nest. This is its nest. And the advantage of that is that in the breeding season, predators use search images to quickly find bird nests and then target them to eat the babies or the eggs. But if a predator looks at this, is that a bird nest? No, it's not a bird nest. It's just a couple branches trapped in another branch. So they'll go right by it. So it's a great camouflage in plain sight. We also have what's called pencil nests, where the nest is supported from its rim, but it hangs down from an attached rim. Or in the case of orioles, we have pendulous nests, where the whole nest is just hanging. It's not from the rim. The whole thing is hanging from meager supports. And we have a few species that do adherent nests, black phoebes and barn swallows, where they take mud and saliva and attach them to vertical surfaces. Barn swallows originally nested in caves, only in caves. Then they switched to buildings in the mid 1800s, and now every barn swallow in North America nests on a human structure. They made a complete switch in starting in the 1800s. And the material of the nest can have a tremendous variety. You can have everything from rocks to spider webs that make the nest. One common ingredient in nests that mystified scientists for a long time is that a lot of nests have some kind of green leaves in them. And for a long time, they thought that this was an aesthetic choice. They were like adding scenery or decorations to the nest, but they now realize that they're using the green vegetation to repel or kill parasites or insects in the nest, like fumigants or something. It's also going to be common to see birds using human materials for nests. And it turns out that birds are fashion conscious. So they did an experiment where they put out pieces of yarn of different colors. And what they discovered is that one color is going to be the popular choice one year, and then another color is going to be the popular choice a different year. And it's thought that what's going on is that females are watching each other and copying each other. They're basically choosing to imitate each other's fashion with color. And you're also going to be familiar with the example of cliff swallows. You've probably seen this before, where you see cliff swallows gathering mud for their nests, and you'll see them at a mud puddle with their wings up in the air, quivering them really fast. And you might wonder, why are they doing this? Well, there's two reasons why they're doing this. One is swallows have very weak feet and legs. They can't perch and stand easily. So when they land in the mud, they would just plop down in the mud and get mud all over the front of their body. So by putting their wings up and quivering them, they create just enough lift that they can just touch down with their feet while they're gathering mud and keep their body out of this gooey, sticky stuff. But at the same time, another reason is at this time of year, males are so amped up that they'll try to mate with any swallow that moves. Basically, a male swallow sees another swallow, attacks and tries to mate with it. If it's another male, it goes, oops, sorry, and flies away. If it's a female, then maybe it has a chance. And so because any swallow can be attacked by these amped up males, if they put their wings up and quiver them, a male can't land on your back and pounce on you. So it's a way of protecting yourself while you're sitting still for a moment. And here's a fascinating thing. They are picking up gooey, sticky mud and taking it to their nest. But how do they get it off their beaks? They don't just sit there and wipe their beak and try to get this icky mud off their beaks. This was a question that people had, and they finally discovered how they do it. What they do is they first gather the mud, just gather up a mouthful of mud. They fly to their nest, and then when they get to the nest, they very rapidly vibrate their bills. And when you vibrate mud, it liquefies it in the same way that when there's an earthquake, the ground gets liquefied and buildings topple over. They vibrate their bills, it liquefies the mud, and then it can fling the liquid mud on, and it makes these little droplets that then instantly freeze in the shape they want. And that's how they get the mud off their beak and how they make their nest. It's a really incredible technique. So then once the nest is finished, birds get to the important week work of laying eggs. And birds are unique because they're the only vertebrates that only lay eggs rather than giving live birth. So we have fish and amphibians that need water for their eggs or else very moist conditions. Then reptiles, birds, and mammals have severed their dependency on water by encasing their embryos inside of an amniotic membrane that creates its own enclosed watery environment. Mammals carry these amniotic membranes and embryos inside their bodies, but reptiles and many reptiles, not all, but many reptiles and all birds add a hard shell around the amniotic membrane so that the embryos can be raised outside of the body. And then birds have taken us one step further by actually incubating their eggs. And this allows them to utilize a far greater range of habitats and conditions than reptiles that just lay eggs and leave them. And then another key difference between reptiles and birds is that the embryo inside of a reptile egg uses protein as its energy source, while the embryo inside of a bird egg uses fat as its energy source. And the advantage of fat is that as it breaks down, it creates water as a byproduct. And this allows birds to lay their eggs in a much greater range of habitats, including very dry places, so the eggs don't dry out. They're producing their own water inside the egg. So a female is going to have a group of egg cells waiting in her uterus, and each one is then sequentially moved down the oviduct and layers of membranes and hard outer shell are going to be added. We're going to show this in a moment, but these eggs are usually laid 24 hours apart because that's how long it takes for all these different layers to be secreted around the egg in preparation for laying. And females usually have a set number of eggs that they will lay, but some species can continue laying more eggs if eggs are removed from the nest. And they did an experiment with a flicker, and they removed every egg from her nest that she laid, and she ended up laying 71 eggs in 73 days because they kept removing them. She kept producing a new one. That's the capacity they have. They don't always do that, but they have that capacity. And the general strategy that a female will do is that they will briefly visit their nest and lay one egg each morning before sunrise while it's still dark out. Then they leave the nest for the rest of the day and all of the next night. This avoids attracting the attention of predators. And she's also going to be watching her nest with one egg in it, in this case, to see if it's a good spot. She comes back. Okay, there's one egg is still there. Okay, this is probably safe. Then she lays a second egg before the sun comes up. Then she leaves all day and all night. Then she comes back. Okay, two eggs. This is good. Lays a third egg, then leaves. And then the morning she lays the last egg that she's ready to lay, then she sits and starts incubating. So it seems crazy to wait until this last egg is laid and leave all those eggs sitting there cold and exposed for days while you wait and lay more eggs. But this works because eggs are not impacted by the cold, and the embryo isn't triggered to start growing until it's heated to the right temperature. So this means that all of those eggs don't start developing until the mother sits on them and warms them up. If she sat on them the first day the first egg was laid, then that egg is going to hatch 1 day sooner than the next egg, and 2 days sooner than the next egg, and 3 days sooner than the next egg. This is called asynchronous hatching. And for most birds, that is a problem because what it means is that your babies grow up at different rates and then they leave the nest on different days, which means that you're going to have some birds flying around off in the branches and the other ones still sitting in nests, and you're going to be flying around trying to find these babies and feed them. It's exhausting. So most birds wait until all the eggs are laid, then start sitting on all of them at the same time. This is called synchronous hatching, and it has the advantage that all of your babies grow up and leave the nest at exactly the same time. And one advantage of incubation is that it allows the parents to keep the temperature of their eggs at a constant around 99 to 100-degree temperature. And to do this, the female, and sometimes the male as well, will develop a brood patch. They drop their breast feathers, and this patch of bare skin becomes swollen with the retained fluids, and they add more blood vessels. And when the temperatures are cold, the bird will heat the eggs by pressing her skin against them to keep them warm. And if it's hot, then she will go and soak her feathers in water to cool the eggs off. They watched a pair of black-necked stilts at the Salton Sea where it's really, really hot. And they were recorded making 115 trips in a single day to soak their feathers in water and come back and cool their eggs off. And another advantage of incubation is that it allows both parents to help at the nest or to escape from the nest if a predator comes along. So let's turn our attention to the egg itself, because the egg of a bird is a marvel of engineering. It's going to be light and strong, and yet it provides the growing embryo everything it needs. Basically, an egg is a self-contained womb that comes in a wide variety of shapes and sizes. So, for example, consider the example of a brown kiwi in New Zealand. Their eggs are 18 to 25% of their body weight and fill the entire cavity of the female. This is an extreme example, but there is a incredible variation in size and shapes of eggs in the bird world. And these shapes and sizes are primarily determined by the shape of the mother's pelvic bones. So, for example, owls have deep pelvic bones, so the eggs are round. And at the other end of the spectrum, we have long, narrow eggs like this, like cormorants have long, shallow pelvic bones, so they need to lay long, elliptical eggs. People long thought that the shape of these eggs were determined by the kind of nests that the bird was using. So, for example, the common murre has a net egg like this, the pyriform egg, they lay their eggs in tiny cliff edges, and the eggs are just rolling around. So if there's a sharp point at one end, the egg isn't going to just roll off. It's going to roll in a tight circle if it's rolling and keep it from falling off. But it's not clear that the shape is determined by the nest site because there's so many exceptions that don't fit that rule. So it's a great idea, but it doesn't quite work. And then eggs are also colored in a fantastic variety of patterns. You have eggs in open nests that tend to be darker and more heavily patterned, and then eggs in dark cavities tend to be white. And these patterns and these colors are all produced by byproducts of bile that are derived from the liver, and then they're painted on the eggs as they come down the oviduct. So there's tiny glands on the sides of the oviduct like ink jets. And as the egg comes down the oviduct, it's spinning. You'll see a diagram of this in a second. The egg is spinning, and these jets are going squirt, 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 and it's painting the egg as it slides past and spins down the oviduct. And it's thought that these unique patterns of each egg help a female recognize her own eggs, make sure she's on the right nest, if that was a confusing point. And let's look at how the eggs are formed. We mentioned this already, but here, let's go through it here. So to start off, all of the potential eggs, all the yolks for eggs are all formed in the ovary. And then one by one, they're sent down the oviduct and prepared for laying 1 day at a time. Because it takes a lot of work to move it down and add all the layers. As it comes down, layer after layer of surrounding materials are incrementally added to the egg as it comes down. And then when the shell is added at the end, then it spirals down this last bit and these jets squirt ink on it and paint it as it comes down and ready to come out. And if you look carefully, all of these parts of the egg, all the layers that are added can be seen if you break open a chicken egg in your kitchen and look closely at it. So the parts you can see are the yolk. We have the yolk here in the center, the first part that's formed. And it takes 5 to 14 days to build the yolk. And it's built out of concentric layers that look like tree rings. We have dark yolk that's deposited during the day and light yolk that's deposited at night. And you can actually see these layers a lot of time when you have a hard-boiled egg and you kind of start breaking it up. You'll see layers pop off the hard-boiled egg. These are these kind of tree rings that are formed day after day as the yolk is built out with concentric rings of material. This yolk contains all of the stored fat and proteins that the embryo needs to develop. And then on top of the yolk is this really important spot called a blastodisc, which is the location of the actual embryo. Remember, the yolk is just food, but the actual embryo itself is sitting on top on a blastodisc. And this is all floating in a liquid bath called albumin, the liquid bath, which provides water for the yolk, for the embryo. It provides insulation from sudden temperature changes, and it provides cushion from impact. It is critical that this little embryo, this little blastodisc, is always at the top. It's always floating on top. It cannot be turned underneath. So as the egg is moved, and the female is constantly turning eggs in the nest to, I don't know why, but they turn them in the nest. And so the yolk is attached to the shell at each end with these chalazas, which are basically like rubber band, stretchy rubber band material that attach each side of the, I don't have a good thing here, but here's the little thing. They attach each side of the yolk to the shell itself. And then as the yolk turns, these can stretch and spin so that the yolk is always turning and facing upright. And when you break open the shell, you can see these kind of mucousy yellow, or not yellow, whitish, milky, mucousy, thick strands that attach the yolk to the shell. They're really important. And we'll talk about this in a minute. It's a really important idea that the yolk can always spin freely. And I'll mention why in a moment. And then the shell itself is made of hard calcium. It has two membranes. There's an inner shell membrane which is the sac that holds the ovum together. And this is the membrane that gets in the way when you try to peel a hard-boiled egg. And then there's an outer shell membrane, which holds the shell together in case it breaks. So if it gets cracks in it, it doesn't just collapse because there's an outer shell membrane and then inner shell membrane inside holding everything together. So this is the process in which embryos develop. So we have the yolk with the little blastoderm on top. Here's the embryo itself. It's just a couple of cells to start out with. These cells start dividing, and as they divide, they line up and form a linear trough. And this linear trough, here it is 18 hours later, has a head end, a tail end. It has a left side, has a right side, has a top and a bottom. It's beginning to form a body. And then this trough makes sides that curl up, fold over, and connect on the top and make a hollow tube, which is the nerve cord. And then everything starts growing around that. You get these somites, 9 pairs of somites that start branching off that become vertebrae and eyes. And then that continues growing into the tiny little embryo over time. So here's the embryo inside of the egg. I'm sorry, this is a lot of information, but I'm a nerd. I think this is so cool. I hope you can follow along. Uh, but here we have the little embryo inside, and it is surrounded by 4 sacs or 4 membranes. There's the yolk sac in black. This is what the sac that's holding all of the yolk that's going to feed the embryo. Then there is a amnion. Let's see, where's the amnion? Right here. It's a light green sac that surrounds the embryo, allows it to move and stay moist inside of its own little sac. Then you have one called allantois here. It's just a little tiny dark thing here, but it's going to expand because this is the sac that holds the waste. As this little embryo is growing, it's pooping and peeing as it develops. It needs somewhere to put those wastes. And then we have the chorion here, the darker green, that basically holds all of the sacs together and protects everything. And this is like a placenta. This is analogous to a placenta. And here's a little bit later. I'm not going to go through the whole sequence, but just a little bit later, you can see the embryo here inside of its amniotic sac, which keeps it moist and allows it to move. And then we have the yolk here. And look what it's doing. It is sending out blood vessels and arteries into the yolk, getting food, moving food into the embryo and processing the food at once. Then we have the allantois here, which is attaching to the shell. This becomes the container for all the waste that a bird produces as it grows up. So you have a little embryo inside of an eggshell. Where is it going to put all of its poop and its pee, right? Wouldn't it just poison itself? Well, humans get rid of our waste with urea, which breaks down, which dissolves in water, and that's how we get it out of our body. But a bird excretes its waste as uric acid, which does not dissolve in water. And because it does not dissolve in water, it allows them to package all of their waste inside of the shell without poisoning themselves. It's a really important thing. We produce waste with urea, they produce it with uric acid. It's slightly different, but it doesn't dissolve in water and it keeps them from poisoning themselves. And then you can see this allantois here, this sac coming off the embryo, also has blood vessels that attach to the shell, which is where it's exchanging gases with the outside world. This shell is a marvelously complex structure. It's made of calcium pillars bound together with collagen. And between each pillar is a little pore. And this pore attaches to the sac underneath it, and then the blood vessels exchange gases. This is basically the lungs of the shell, right? And these pores, there's about 17,000 pores in a shell, are so important that you can take 1/10 of half a drop of oil and put it on the shell, and it's going to kill the embryo because it can't breathe. You're plugging all of the pores with oil. It's absolutely critical that they can breathe through these holes. And then on the day of hatching, there's going to be a lot of changes outside of the egg. The parent's behavior changes. So earlier in the nesting process, they're inclined to abandon the nest if they're disturbed because they haven't invested a lot of energy into the nest. But by the time the eggs are ready to hatch, the parents have invested a ton of time and energy into the nest. They become very secretive and very quiet around the nest. And then if the nest is disturbed, they will vigorously defend it rather than just fleeing and abandoning the nest. And then inside the egg, the chick has to make a very difficult transition. It's been breathing through a network of vessels through the shell. Now it has to start breathing on its own. The first thing it does is its little thing here, it pierces the membrane, the inner membrane with its beak and starts breathing from this air sac that's accumulated at the end of the egg. And so it starts breathing this, which means it has a limited amount of time to get out of that shell. It's curled up in a little fetal position, and it has a little calcium tooth on its beak, and it pulls its head up and begins hitting the shell from the inside. At this point, the shell is weaker because the bones of the developing bird have absorbed calcium from the shell. So the shell is weaker. They punch up with this little tooth against the shell, and they do it over and over again, punching up and rubbing until they put a hole through it. That's called pipping. Then what they do when they have a hole is they kick with their leg and turn and do it again. And then kick with their leg and turn and do it again. And they make a circle of holes and then pop off part of the shell like a trapdoor. This is why it's so important earlier in the development process that the yolk does not stick to the shell. Because if the yolk sticks to the shell, that means that that little embryo can't kick and turn. It's going to be stuck in one place and kick all it wants, but it's stuck to the shell. It can't move. It can't create a circle of holes and pop out. So that's why it's critical that they're able to turn in the shell. This process of breaking through and getting out can take 5 hours or can take 4 days. Um, but then as the chick is emerging from the shell and getting ready, it starts making a distinctive piping sound that alerts its parents and also communicates to all the other eggs in the nest. This is the moment, and they all synchronize their hatching at the same time. Let's see. So we got a couple more slides. I know we're getting towards the end of the time, but just a couple more slides. And I mentioned this earlier, if all the eggs hatched at the same time, what is this called? This is called synchronous hatching. And the advantage for parents is that it's more efficient if all your chicks are the same age, they're going to need the same food, and they leave the nest at the same time. But at the same time, some parents utilize asynchronous hatching, which means they start incubating the first egg as soon as it's laid, and it means the eggs are going to hatch on different days. So the advantage of asynchronous hatching is if your food supplies are unpredictable, because what you do with asynchronous hatching is you feed the oldest and biggest chick first, and you keep feeding it until it's full. Then when it's full and satisfied, you start feeding the second oldest chick until it's full. And then you feed the third oldest chick until it's full. And if there's enough food, then all the chicks get fed. But if it's a year when there's not enough food, then you're guaranteed that at least your oldest chick is going to survive versus trying to feed all of the chicks the same amount over and over again every day. So it's different strategy for different reasons. Asynchronous hatching is mostly used by raptors, for instance, that need to hunt for their food and it's not dependable. And it's mind-boggling how much work it takes to feed growing babies. Some baby birds increase their weight 50 times in 3 weeks, and all of this phenomenal growth is fueled by a prodigious amount of food. And just to test this out, scientists tried feeding a baby robin as much food as it wanted to eat, and the baby ate 14 feet of earthworm before it was satiated. That's a ton of work, and imagine doing that for a whole brood of babies. That's an incredible amount of food. A tree swallow has to collect an average of 8,000 insects a day to feed its babies, and they recorded a male house wren feeding its babies every 47 seconds for an entire day. And keep in mind also that some chicks are fed by the parents at this rate for up to 10 weeks. So just a tremendous amount of effort. And one strategy to get away from that is to take the burden off the parents by having what are called precocial chicks. So precocial chicks, like this killer here, are born, come out of the egg already have well-developed feet and legs, and within moments of hatching, they're already running around finding their own food. And then the only reason they need parents is to watch over them and protect them from predators and make sure they're safe as they grow up. So that's a way of taking the burden off the parents. But most birds use altricial chicks, and these are chicks that are born naked. They're blind, they're utterly helpless. They can open their mouths, they can swallow, they can digest, and they can poop, but that's all they can do. Basically, their sole function is to eat and grow. And they are born with these vividly colored mouths like this, so the parents know exactly where the food needs to go, and they can feed them quickly and efficiently. The babies are also born with swollen hinges at the corners of the mouths that are loaded with nerves. So the babies spring open their mouths at the slightest touch or the slightest breeze. You can see in this case that they're very pink from muscles and blood vessels under their very thin skin. At this age, they cannot even heat themselves, and they need their parents to keep them warm so that their digestion and their growth hormones stay active. And because they aren't wasting any energy trying to stay warm, they can turn all their calories into phenomenal growth. And if you've ever watched a bird nest, you know the bird babies grow incredibly fast. And within a couple of weeks, they're already beginning to flap their wings. And then as they leave the nest, they will fly away to nearby vegetation to avoid being found by predators and begin dispersing out into the world. And then there comes the moment we've all been waiting for. It's time for the babies to leave the nest and learn about life on their own. At this point, the parents have invested a ton of energy and effort into this process, and they've taken far more risks and made more choices than you might have realized that they're making. And there's obviously a lot of different ways to make nests and raise baby birds, but there's ultimately no single way that's the right way or even the best way. They're just different ways that work for different reasons at different times of the year for different birds. So let's see if there's any questions. I hope there's people there.
Yeah, feel free to enter a question in the chat, or anyone in the audience, just raise your hand. Yeah, in the back.
I'm curious, David, as far as, let's say for robin, do you know, like on average, how many sperm they would have?
No, I don't. I've never seen that number in a book, but I'm sure that there's some highly technical volume where someone has tried to calculate that.
Do birds steal nests from other birds?
Oh, yeah. Yeah. I mean, it's a lot of effort to build nests. So, I mean, you see all kinds of fighting in the breeding season. And a lot of it is they're fighting over territories, they're fighting over food, they're fighting over mates. But yes, they can easily steal each other's nests. And in some species, this is a real problem. But even another problem is, well, why steal a nest when you can just lay your eggs in someone else's nest and let them raise your babies? And the more eggs you can dump in other nests, the more babies you've raised without putting any effort into it. So that's more of a problem. That's not worth fighting to steal a nest when you can just dump your eggs in it and let the parents raise your babies not knowing it. And in cases like cliff swallows, where they all nest in these giant colonies, the rate of brood parasitism, it's called, is phenomenally high. They're continuously watching each other and flying in each other's nests and dumping eggs everywhere they can. And they'll do that the whole season long. So that's where they probably put more energy than stealing nests, is just let the parents stay there, let them raise babies, but dump your eggs in it and let them raise your babies too.
Yeah, go ahead.
Question about all of those nests that the male, I think it's marsh wren makes, like 20 nests to kind of impress the female. Or try to, show what vast territory they have. What happens to all those nests? I mean, do other birds come along and go, well, this is nice?
Great question. I love that. No, marsh wrens are fascinating and incredible birds. And not only that, but the male wants to attract a harem of females. It's not just for one female. So he'll make 20 nests, show off to one female, then he'll do it all over again. He'll build another 20 nests and try to attract another female, and then build another 20 nests and do it again. So that's his strategy. Well, they sit there, right? The advantage of that is that you have empty nests all over your territory. And what happens when a predator comes along? It sees a nest, checks it out. Boom, empty. It sees another nest, checks it out. Empty. It's like, this is not a good place to go, and keeps going, right? But if it finds a nest with eggs in it, then it's like, oh, yummy food. I'm going to find another nest, and then it's going to stay. So the more dummy nests you have around, it dilutes the chances that a predator is going to find the active nests and linger in your territory. So there's another advantage to building all these nests and just abandoning them. It's not a wasted effort. It actually acts to divert the attention of predators. Great question.
So, how much security does a birdhouse provide compared to a nest in the trees?
I don't know how you would measure that. I think it's pretty good. They got a roof, they got hard sides, but then at the same time, there's a hole that you can only go in and out of the hole. So if a predator comes and sticks his face in the hole, there's nowhere for you to go. Whereas a cup nest, you could go out 360 degrees quickly in any direction. So there's probably pros and cons. You're protected from some predators, but in other cases, it might be a dead end and a trap. And it might be a protection from rain, but it might be other disadvantages. Does that sound right?
So do birds prefer to make their own nest rather than to occupy a birdhouse?
Judging from how many birds are fighting over my nest boxes right now, I think it works. It's a mixed bag. I mean, there's birds that would never ever use a nest box. There's other birds that love nest boxes. Some that probably go back and forth. The nest boxes are used by cavity nesting birds. They're not going to be used by birds that make a cup necessarily. So birds need cavities. There's not a lot of cavities anymore because people cut down so many trees. They clean out trees that are dead and diseased. And so cavities are in extremely limited supply now that humans have changed the landscape so much. So there's a great advantage of putting out nest boxes because you're helping fill in the gap of the missing cavities that are there naturally. And it's one of the best ways you can help bird populations is by putting out cavity nest boxes. Does that answer the question?
I just want to say, David, thank you very much for your excellent presentations. We have enjoyed them, and perhaps we'll have you back next year with a new topic.
All right. I just put together a bird migration talk, so that's a new topic. And please, everyone, sign up for the newsletter. My Lucas Guides newsletter comes out every week. I cover incredible topics, and I always mention this. I have a few copies left of my Sierra Nevada Birds. If anyone's interested, I can send you a signed copy of it. It's an incredible little compact field guide companion. You probably already have it, but if not, there's only a few copies left, so let me know if you want one. Otherwise, thank you so much, Central Sierra Audubon. It's a pleasure to speak with you, pleasure to be part of your programs again, and I look forward if I can get back. Thank you, everyone.